We're going to move into lesson 2A5, and this is going to be an important day. Hopefully you're not absent on this day. And we're going to talk about the rational zero theorem. And this is actually a pretty big deal in trying to break down polynomials into their parts, because when you look at these things, you say, how in the world am I going to factor this? Well, synthetic division is going to be one of our friends, and we go back to one of our earlier theorems that a polynomial, a higher degree polynomial, can always be broken down into its linear component and its quadratic, even though those quadratics may be irreducible. And this is where this is one of the tools that we're going to use. So I just want to revisit a couple of one main concept, and that's the repeated zeros of polynomial. This is when we talked about multiplicities. So if I had like x minus 2 to the squared, that has a multiplicity of 2. And if it's an odd or an even multiplicity like this example, it's going to be tangent. If it was odd, say that was the third power, it's going to cross. Now the reason is that when we have something that is tangent, our f of x stays positive. The sign changes if it was above or below. And if it was odd, you're going to get a sign change. And we're heading into this. This is actually an important minor consideration that we have as we go into all this. So the rational root theorem is just this. If p over q is a rational number, and this is a conditional statement, we have our if-then statement, and a zero of the function, so this is an important part, these both have to be a condition, then p is a factor of the constant term and q is a factor of the leading coefficient. Okay? We can also look at the converse if we needed to, but basically in simplistic terms, my leading coefficient is going to be q, my constant is going to be p, and we're going to look at all the possible zeros of the function by doing p over q. Best shown in an example, because you're going to read this like 3 times and go, huh? That's okay, I did that too when I was a student. All right, so we're going to find all the possible rational zeros. This doesn't mean it will be. Like for instance, this is a third powered polynomial, and we can only have 3 possible zeros at most. There may only be 1, and the other 2 could be complex. We don't know. So what we're going to do is we're going to list all the factors of the constant term, this guy right here. We're going to list all the factors of the leading coefficient, which is a 1. And then we're going to create all the fractions possible. Well, all the possible factors of 8 are plus or minus 8, plus or minus 4, plus or minus 2, and plus or minus 1. And we're going to put them all over our possible combinations of plus or minus 1. So all our possible rational zeros are going to be plus or minus 8, plus or minus 4, and it's real easy when the leading coefficient is 1, plus or minus 2, and plus or minus 1. That's a lot of possible zeros. We got 2, 4, 6, 8 possible zeros. And at most, we're only going to have 3. So we say, well, which ones are they? Well, that's where your synthetic division is going to come into play. But I'm also going to show you another theorem after we talk about Descartes, and that can narrow that down some. Alrighty, let's take a look at one more example on just finding the possible rational zeros. So I'm going to take this, and I'm going to call that my p, and here's my q. So I'm going to do plus or minus 6, plus or minus 3, plus or minus 2, and plus or minus 1. And this is all going to be over my possible ones of plus or minus 2 and plus or minus 1. So that's 6 over 2, that's going to be 3. So this is going to be plus or minus 3. Then I'm going to have 6 over 1, so that's going to be plus or minus 6. Then I'm going to have 3 over 2, that's going to be plus or minus 3 halves. And then I'm going to have 2 over 2, so that's going to be plus or minus 1. I'm going to have 2 over 1. I'll just keep it right here, plus or minus 2 and plus or minus 1. So 1, 2, 3, 4, 10 possible roots. And again, at most we can only have 3. So let's try and lead into our next phase. So what we have is we have a whole bunch of possible roots for this one. We have 26 plus or minus 26. plus or minus, well, there's not that many, 2 and 13. And that's it. Actually, there's not that many possible roots. But I'm going to tell you that 2 is a possible root. We kind of knew that because 2 and 13. So what we want to do to confirm or deny it, or affirm or deny, is let's do synthetic division real quick. All right. So that's going to be a 1, 4, negative 25, and plus 26. I didn't need to write the positive. All right. Bring down that 1. So 2 times 1 is 2. That's going to be 6. 2 times 6 is 12. That's going to give me 13. And 2 times 13 is 26, right? I'm sorry, negative 13. And that's going to be negative 26. That gives me 0. This confirms it, that yes, 2 is a root. So we know that we have x minus 2 times something if we were to factor this out. Okay? And that something will be x squared plus 6x minus 13. So x squared plus 6x minus 13. To find the other roots, we can factor or do quadratic formula, complete the square, whatever. So let's go ahead and take a look at this one. So here I have a whole bunch of possible roots. Good grief. 20 over 2, 10 over 2, 5 over 2, 4 over 2. There's a whole bunch of possible roots on this one. And so, oh my goodness, which ones do I choose? Well, we're going to just pick one in this exercise. This is just an exercise. And we're going to pick negative 4. So here we go. I'm going to do negative 4. I'm going to do synthetic division. And I got 2, 3, negative 20, and negative 20. Okay? I'm going to drop down the 2. Oops, didn't mean to do that. So drop down the 2. So negative 4 times 2 is negative 8. I didn't do a very good line there. That's going to give me a negative 5. Negative 4 times negative 5 is a positive 20. All right. Well, that's going to give me a 0, and that times 0 is going to be 0. So what I have here is negative 20. All right. So this would be a no. I have a remainder. So this is not a root. Alrighty, so that's where we're going to leave off, and I will pick this up. I mean, this is all the same lesson. I'll pick up part 2 in a moment.